Quotient rule, it's lovely. If you can write a function looking at it as it's a rational function, so you could look at a function in the numerator, a function in the denominator, you have the right to find the derivative by using that lovely beast right there. So we've seen that. Now that should look a lot like the product rule in the numerator. In fact, without the denominator, that is the product rule, just with a subtraction sign there instead of a plus sign. Well, so let's think of this. What if we have this function, y equals x to the 7th divided by x to the 3rd? We could do this a happy way, a bummer of a way, and a horrible way. So let's explore. Look at here. We could say, you know what, that's just x to the 4th. Woohoo! If y is x to the 4th, I take the derivative, I'm done. Or we could say, let's have some fun with the product rule. I could write x to the 3rd in the denominator as x to the negative 3. So I could look at my function as the product of two functions like that. So the derivative would be, the derivative of f of x, that first one is 7x to the 6th, leave the second one alone, plus, leave the first one alone, take the derivative of the second one, carry the 3, add the 2, you do this, and then do, oh look, we get the same answer. So that's the product rule. Hey, how about we do the quotient rule instead? Alright, so there's f of x, there's g of x. Quotient rule. Take the derivative of f, leave g alone, minus, leave f alone, take the g derivative, and then divide it by g squared. If we keep messing with that puppy, then we'd have 7x to the 9th minus 3x to the 9th divided by x to the 6th. Clean up the numerator, then divide it by the denominator, and wow, we get the same result. So look at that. If you think about this, there's a few things to gain from this. One of them is that you always have the right, if you want to write the quotient rule as the product rule. Just take what's in the denominator, bring it up to the numerator, and write it to a negative exponent if it makes the problem simpler or whatever, because the math will work out the same way. But you always want to look to simplify if you can, because those two rules, both of them, can be tedious. So the best thing I could say regarding the quotient rule is, don't use it, all right? Try at all costs to avoid using the quotient rule. If you get to a test and you see a bunch of problems that are fractional, it's like, oh my gosh, I'm going to have to use the quotient rule over and over and over again. Odds are the teacher is trying to get you to see that if you would simplify those things, you could solve them right away. Case in point. Whoa, look at that bad boy right there. That's clearly a function divided by a function. Can you imagine how much enjoyment we would have if we used the quotient rule in that puppy? But we don't need to. If our math skills are good enough, we realize that if that trinomial with 3 terms is divided by that monomial, then what it means is each term up here is divided by that monomial. So, and this is where sometimes we get so busy doing calc or pre-calc that we kind of pull our brains out and play with them, and we miss the obvious when it comes to our algebra or even our arithmetic skills. Hey, look at that. I think we can reduce that down. 14 divided by 7 is 2. X to the 6th divided by x squared is x to the 4th. Minus 4x squared plus 3. Oh yeah, that's a little bit better. Now if that's what y equals, let me find the derivative of y with respect to x. This could take a while. Okay, we're done. So there it is. I know we missed the enjoyment of spending 4 minutes on a test applying the quotient rule to that bad boy, but always, when you see a quotient rule opportunity, say to yourself, I don't want to do it. I don't feel like doing it. Is there something I can do to simplify? And a lot of times there is. If not, well, too bad. Yeah, now here. I wish we could simplify this, but I don't know, that doesn't look possible. Of course it's possible. All we have to do is say, I can rewrite this with negative exponents. Use fractional exponents and negative exponents whenever you can. Simplify before you jump into doing some long, arduous problem. So this is 7x to the negative 5 minus 2x to the negative 3rd. But do you agree we're going to have to use the quotient rule there because we have a variable over a variable? Time out. pi is a number, like 2, like 7, that's a number. It's a coefficient. So all you have to do is write this as pi times x to the negative 1 power. Then the derivative of this, just use the power rule on that thing. So it's going to be negative 35, right? Negative 35 x to the negative 6 plus 6 x to the negative 4 minus pi x to the negative 2. Then take all these negative exponents, toss those puppies on the bottom, you got that one done as well. Now the same thing goes for avoiding a product rule. You look at this puppy right here and go, holy monstrosities, we'd have to take this is f of x and this is g of x. Think of the hours of fun enjoyment we could have with that. Well, it'd be only minutes, but still, it'd be a blast. But instead, how about we realize that this quantity, this binomial, is the same as this binomial. One of them's being risen to the 5/3 power, the other one's raised to the negative 2/3 power. When we multiply powers with like bases, we just add the exponents to keep track of everything. So what you're left with is this binomial raised to the 3/3 power, which is raised to the 1st power. So all you're left with here is 7x squared minus 13. That's what this function really equals. So if we take the first derivative, we're going to get 34x, and we are done. I know, maybe we feel guilty. It's like, I could have been doing a lot more math, and I feel like I'm cheating by simplifying problems before we even try to have to go to the product rule or the quotient rule. But you're not cheating, you're just being a wise mathematician. So, avoid the product rule and the quotient rule at all costs. So promise yourselves that you're going to look to simplify things first, use good algebra, use good arithmetic, and calculus becomes a lot more doable.